Hello friends, welcome to the new topic, that is signal flow graph. Now in control system we can represent a control system either by using a block diagram representation or by using a signal flow graph. Okay. Now the disadvantage of block diagram is that it looks bulkier and it contains number of summing boxes, number of blocks, or number of takeoff points, and whereas this eliminates the use of these type of blocks, summing boxes, or takeoff points. Okay, so we use signal flow graph in this case. Now in case of block diagram, where this A represents the transfer function of this path, where this path is denoted by this yellow line. Okay, this is your transfer function, whereas in this case this A denotes the transmittance of the path. Transmittance of the path. Okay. Now, in this case, this input is known as reference input and this output is known as controlled output. Whereas in this signal flow graph, this x1 is actually your input node and this x2 is your output node. If you compare the outputs of both these two, then you can say that this in this particular case this is equal to x2 is equals to a times x1. Similarly, here in this case also this x2 is equals to a times x1 and both are same in this case. Okay. Now here this path is very important and the path contains an additional information that is direction of the signal in which it is flowing, and this A, that is transmittance of this path, may either be your positive value or it may be a negative also. So let's have an example here first. Suppose we are using a block diagram here like this. It consists of a signal or block with transfer function A, and here it has a transfer function B, and we are given it with a positive sign where this is connected to the feedback with C, and this is your takeoff point, and let us suppose this is your x2 and this is your x1. Then how can we represent this signal flow graph? Then we have to replace this each path or each block with this its transfer function written on it like this. Here from x1 to this node, this becomes here intermediate node. Okay, so we have to start with x1 here. This is x1. From x1 to the intermediate node, let us suppose it is x3 here, and having a transmittance b, whereas x3 to this another node, this is also an intermediate node like this, and its transmittance is a. And here let us suppose for this part the transmittance is 1, and this is your x2, and this is your x4, and there is also another feedback flow in this direction, in this case, that is from this side to this side. So we have to take care about this. This is x4 and like this. So this is C. However, we have used plus sign here, so this should be plus here. Okay. So when we calculate its transfer function using signal flow graph, okay, we have to proceed in this way. We have to calculate the value of each node except x1, or you can say that we have to calculate the value or expression for each node in terms of this x1, like in this way. Here x3, as there are two incoming nodes, one is this one and another is this one. Okay, so x3 will be equals to x1 multiply b plus here x4. Okay, this x4, you can see here, this is your x4 multiply c. Similarly, we can use this method for x4 node. x4 has only one incoming node, so x4 is equals to x3 a, and x2 has only one incoming node, that is 1 multiply x4, or you can say that it is just simply x4. So you can also write this expression as x2 is equals to x3a. Okay, so in this way, if you find out x2 divided by x1, that is your transfer function t, this will be equal to a b divided by 1 minus a c. You can solve these three equations, that is equation number 1, equation number 2 and equation number 3, and you can easily reach at this result. So this is similar in the case which we have received earlier using block diagram representation. Now look at this part AB. Here AB is actually the forward path. Okay, the transmittance of the forward path. So you can write it as AB is equals to P1, where P stands for path and 1 its numbering is the forward path transmittance. Okay. Second thing is, here you can see the AC. This AC is actually the loop transmittance. Here you can see this loop here. Okay. Where loop is forming when we start from a node moving in the direction of arrow and reached again to the same node without tracing a node repeatedly. Okay, so here this gives you, let us suppose this is your L1, so we can write this L1 is equals to AC, and this is loop transmittance. Loop transmittance. Okay, so we can write this T as P1 divided by 1 minus L1. Now take another example. Suppose we are having this part and having nodes at this point. Let us suppose this is node x1, second node is at this one. Let us suppose this is node x2, second is 3, the third is this x3. Let us suppose this is your x4, let us suppose this is your x5, and let us suppose this is your x6. Suppose this has transmittance A, this has transmittance B, and suppose there is a feedback here with the transmittance this, and suppose we are having leave it, suppose the feedback is at this position and at this position. Okay, so in this way you can use it like this. So A, B, C, D, E, F and G, where A, B, C, D, E, F, G are the transmittance of each of this path, and X2, X3, X4, X5 are intermediate nodes. Okay, and this X1 is the input node and X6 is the output node. So writing the equations for each node, X2 is equals to AX1 plus CX3. X3 is equals to BX2, or you can write it like this, ABX1 plus BCX3. Now X4 is DX3 plus FX5. So you can substitute the value of X3 here. So ABD X3 plus BCD X3. No, this must be X1 here. Okay, plus Fx5. So in this way you can proceed and reach at x5. x5 is ex4 and x6 is gx5. Now solving these equations, for x6 by x1, because this is the total transfer function of this signal flow graph, so we will reach at this point, that is t is equals to a b d e g divided by 1 minus bc plus ef plus bcef. Now look at the graph. A B D E G, where this A B D E G is actually forward path. See here. Okay. And its value is A B D E G. Now here you can also look at this loop and this loop. Suppose this loop is L1 and this loop is L2. So L1 is equals to BC, where L2 is equals to EF. Now if we substitute these values in this transfer function, then we find that this can be represent like this: 1 minus L1 plus L2 plus L1 multiply L2. Okay, you can also represent L1 multiply L2 is equals to L12. Now see another case. Suppose we have this signal flow graph. Okay, and we have a node at this position x1. We know have a node at this position x2, x3, x4, x5 and x6 with some feedback at or forming a loop at this position and this position. So let us suppose we are having this signal flow graph. Okay, so here this is A, let us suppose this is B, this is C, this is D, this is E, this is F and G. So proceeding in the similar way, writing equation for x2, x2 is equals to ax1 plus cx3, x3 is equals to bx2 plus ex4, x4 is equals to dx3, x5 is equals to fx4, x6 is equals to gx6. Now solving these, equations for x6 divided by x1, we reach this result, that is t is equals to x6 by x1 is equals to a b d f g divided by 1 minus bc plus de. Now if we write this loop transmittance as L1 and this loop transmittance as L2 and the forward path transmittance as P1, then you can replace this value as P1 divided by 1 minus L1 plus L2. So proceeding in this way, we reached a question here that what would be the possibilities if there are two number of paths. Then in that case, we have to take another example. Suppose we are having this example here and here like this and this. Okay, suppose there are, this is a node, this is a node, this is a node, this is a node, and here this is x1, this is your x2, this is your x3, and this is your x4. Let's suppose there are two forward paths here and there is no loop forming. So here let us suppose the loop path transmittance A, B, C and D. So in this way your x2 is equals to A x1, x3 is equals to C x2 plus B x2 and x4 is equals to dx3. So solving for x4 divided by x1, we have a b d plus a c d. You can write it like this because here there are two possible forward paths. First one is you can go in this way from this to this side and this side, and in second path you can go in this way and this side and this side. Okay, so let us suppose this is your path P1 and this is your path P2. If you multiply this gain, that is ACD, then you can reach at, sorry, let us suppose this is your P2 and this is your P1. So ACD is this one, okay, and ABD is this one. So in this way we can proceed. Now take another example. The picture will be more clear from next example. That suppose we are again having a signal flow graph like this. Okay, and okay, then I have to draw a freehand curve here and a curve at this position. Let us suppose this is having direction like this and this is having direction like this. Let us suppose this path has direction like this, okay, and this path has the direction like this. So here the loop transmittance, suppose this is your node x1, okay, and this is node x2. Suppose these are intermediate nodes x3, x4, x5 and x6. and here A, B, C, D, E, F, G, H are the path transmittance. So here there are two possible paths. You can see here you can move from this point to this point, this node, and from this node to this node, and then to the final output node. Starting from the input node to the output node. This is your, let us suppose this is a path P1. This is path P1 has the loop path transmittance as A, C, D. Suppose another path is there, as you can see from this side, that is this one is the path. So in this way the P2, this is your P2 forward path, is your E, F, H, and there are two loops. One is this one and another is this one. So suppose the loop one is, this is your L1 with loop transmittance BC, and this has L2 with loop transmittance FG or GA. Okay, this is your L2. So in this way you can proceed for T1 because there are two possible paths. So you can write it as here P1 divided by 1 minus L1, and transfer function T2 for separate path is P2 divided by 1 minus L2. Now solving for x2 divided by x1, because x2 is the output node and x1 is the input node, so we can add these two transfer functions because they are in parallel. So finally we came to the conclusion at this position that we can write here P1 divided by 1 minus L1 plus P2 divided by 1 minus L2. Or solving for this, we can reach here at P1 multiply 1 minus L2 plus P2 multiply by 1 minus L1 divided by 1 minus L1 plus L2 plus L1 L2. Okay, and substituting the values for P and L, you can easily calculate its final answer in terms of their transmittance. Okay.